This is a question of CSIR-NET, and this question actually based on a concept of power series and a holomorphic function. Actually, this question is a direct result based question, and in this question we have given that T is a unit circle and D is a open unit disk, and question gives that for Z0 belongs to R, there exists a holomorphic function f in UZ0 such that f of z equals to summation of z power 4n in this domain. Actually, according to this question, this domain is important. For simplicity, I draw this graph where T is a boundary and D is the inner of the circle, unit circle, and for Z0 belongs to T, I draw UZ0 such that UZ0 intersection D is blue colored. Now for this result first is, if function is analytic at a point P in this domain, then function which is equals to this power series is converges in this domain for some rho greater than 0. For this result, fz work as some function of this power series which is in GP series. This further equals to 1 upon 1 minus z4. And now results 2 is the power series summation z power 4n has radius of convergence 1, which can be findable using this formula, and circle of convergence for this power series is mod z is equals to r, which is equals to 1, because here center of convergence is 0, and with the domain of convergence is equals to z belongs to C, such that mod of z is equals to 1, except z is equals to 1 minus 1 iota minus iota. This implies that from results 2, the power series summation z power 4n is not converges at this point, that is z is equals to 1 minus 1 iota minus iota. We say this point Q, and this implies that there does not exist rho greater than 0 such that this power series has convergence on this, and this implies that function is not analytic at this point. So from result first, this implies that fz cannot be equals to this power series in this domain for this point, and this implies that only z naught equals to 1 minus 1 iota minus iota not belongs to R. This implies that R equals to T minus 1 minus 1 iota minus iota, and from this we can say that R contain all point of T, so option 1 incorrect. R contain infinitely many point of T, this implies that option B is correct. R contain all point of T except a finite set, this implies that option C correct. R contain no point of T, this implies that option D incorrect.